Hi guys, my name is Arthur. This is Wesley, Joseph, Ezra, Nathan, and Tiancheng, and we are Team FISH, or Fully Integrated Sonic Hardware, Team 969. What we're doing today is we're showing you guys a discrete coprocessor capable of duplex communication underwater that works with any I2C or serial device. Now, we're going to demonstrate the system by building an underwater remotely operated vehicle that utilizes our system to send telemetry to and receive instructions from a remotely operated base station. Now, our goal here is to maximize the effective range and data rate of our product, as well as minimize the cost and design complexity.
Compared to radio frequency electromagnetic waves, acoustic waves exhibit considerably lower attenuation underwater, enabling the possibility of long-range underwater communication. Our system uses ultrasonic transducers to both send and receive signals. The effective range of our product is based on our ability to filter noise out of the signals and on the carrier frequency's attenuation underwater. The figure on the bottom right is a simulation of the received voltage as a function of frequency and distance. As you can see, the higher the frequency and the higher the distance, the lower the received amplitude. Based on this and the acceptable signal-to-noise ratio of our receiver circuitry, a conservative estimate of our maximum range is between 100 and 1,000 meters.
It says 100 meters, okay.
Our system consists of a TI MSP432 microcontroller on the block diagram there, running TI's real-time operating system. In it, we have processes to encode and decode data and send that data out to our analog circuits and receive it from the transducers, and of course, to relay signals from I2C or serial. So, all right, on the sending side of our circuit, we amplify digital outputs from our microcontroller into high frequency, very high power short pulses of ultrasonic waves, and those are decoded by our high quality active filters on the receiver side, and the microcontroller then decodes the timing of those pulses into signals that we can then decode.
Yep, so we have already shown reliable short-range communication underwater for under $100 per device compared to over $1,500 for competitor products. Now, we expect to deliver a complete coprocessor by the end of next semester. So come by or stop by our booth to see a live demonstration of this in action, and we thank you so much, and do you have any questions?
Sorry, are you gonna like test this in a lake or something so you can actually?
Correct. We've done initial testing in pools and in a small tank downstairs, and we'll be doing a test in a lake shortly.
What are you testing on? What's your vehicle?
Right. The ROV is, Nathan, you want to explain this?
Yeah, the ROV platform is what we're building to kind of test the effective range and quality of our coprocessor system. So the ROV's purpose is to serve as that test platform so that we have something that can be used to determine the effective range and like data transmission capabilities of the platform.
Is the ROV mobile or is it just stationary?
It's mobile. It'll have motors, so it can move in a 3-axis direction, go up, down, forward, backwards, side to side.
So is the range 1,000 or 100?
I don't know yet.
No, it says 100
Yeah.
over there, so I think he said 1,000.
A conservative estimate is somewhere between 100 and 1,000. We're not entirely certain yet, but it's between that range.
So the question comes here.
Yeah.
Oh,
Yeah.
okay.
Yeah, the minimum range is certainly 1 meter. The maximum range is between 100 meters and a kilometer. We're not entirely sure of that value yet.
Okay.
Yeah. Can you tell us something about the amplitude and frequency of your sound source?
Yes, so we transmit at 200 kilohertz, and the amplitude of the voltage that we send to the transducer is about 20 volts right now, but we have the capability to amplify it up to 200 volts using the circuits that we've designed. So that signal consists of very short pulses of 200 kilohertz ultrasonic waves.
What was your biggest hurdle to overcome at this point?
Ezra? Well, we had several difficulties in actually building the receiver circuit. Mainly, the op amps that we used kept burning out. We had several issues with the MSP432 boards, but all in all, those have been mostly resolved at this point. So,
Was getting this with speakers or anything an issue at all with that?
Initially characterizing the speakers as in transducers was a bit of a challenge because we didn't have the full equipment to do proper range testing on those transducers. However, we've been able to manage by measuring the impedance and other characteristics manually.
All right, let's thank the team.